Hey class, we're doing section 14.2 now, dealing with specifically arithmetic sequences, not arithmetic sequences. Arithmetic is a noun. It's what little kids do in first and second grade. Arithmetic is the adjective that describes the type of sequence or series it is. And this is all based on linear, continually adding or subtracting the same amount each time. That's what an arithmetic sequence is. For instance, don't pay attention to this yet. For instance, this right here, if my first term is 5, my second term is 7, my third term is 9, what am I continually, repeatedly adding each time? It's 2, right? So that's the idea of I'm always adding that same amount. So this is why the formula then works. If you want to jump to your nth term, maybe your 10th term, if you want to jump to your nth term, we'll start with the first term and add a whole bunch of d's, d for common difference. Well, the difference is 2, right? Well, if I want to get, and think this for a second, it seems odd until it just obviously makes sense. If I am at term number 1 and I want to get to term number 10, how many differences do I add? And the answer is not 10. You're already at 1. If you've already taken a step, how many more steps do you need to take to get to 10? 9 more, right? So that's why there's always a 1 less. Whatever steps you've taken, you don't take that many more. You don't take that many steps you don't use those, you don't count those, you've already taken them, right? So this right here, my common difference is 2. So to find my 10th term, it's going to be my first term of 5. What step do I want? How many have I already taken? Times 2. So this is going to be 5 plus 9 times 2. That's 5 plus 18. That's 23. So my 10th term is 23. So that's how I build those sequences. What if I turn this into a series? A series, you remember, is just changing those commas to addition signs. And I know that maybe I want the summation of the first 10 terms. Well, what is that 10th term that we found? 23, right? How then do I add? There's got to be a faster way to add all these up than just one at a time. Let me just show you something amazing. Carl Friedrich Gauss came up with this back in I don't know, late elementary, middle school. One of you did the Carl Gauss, I think, as your mathematician thing. But if I write these 10 terms out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I add those, I could add them together. 5 plus 7 is 12, plus 9, and so forth and so on. What Carl Friedrich Gauss noticed, and we may as well, what is 5 plus 23? That'd be 28, right? What's 7 plus 21? Well, that's 28. What's 9 plus 19? That's 28. What's 11 plus 17? That's 28. What's 13 plus 15? That's 28. Every one of those pairs is 28. So you don't have to, you don't need to add all the middle stuff up. All you need to know is what's the value of the pair and how many pairs do you have, right? The value of the pair is just the first plus the last. The first plus the last. The number of pairs you have is going to be the total number of numbers, that would be n, divided by 2. Sweet. So that works out pretty swiftly, pretty nicely. So in this case right here, the sum of our 10 terms is going to be 10 divided by 2 times our first number, 5, plus our last number that we found to be 23. That will be 5 times 28, which is 140. So pretty slick, right? That's the arithmetic sequences and series. I know there's a whole lot more in the homework than just that right there. But as always, if you have any questions, give me a holler.